What is a Boolean? Have you heard of a Boolean? If you haven't, a Boolean is something that is either true or false, kind of like a statement. So, okay, a Boolean is true or false. True or false. And there's a branch in mathematics called Boolean Algebra. But you say, how can we count with true and false? Well, firstly, because we will actually want to count with it, we just convert true and false to numbers. And if you had to choose which numbers should represent true and false respectively, which numbers would you choose? Well, of course, 1 and 0. That's just logical, okay? So we have that true equals 1 and false equals 0. And here's when you do this, when you choose these numbers, things start to make real sense. Okay, so firstly we can note that, okay, if we have a statement, we can call the so-called logical negation of the statement, meaning that we're just adding a not in front of that. So if you have a statement P is true, then the logical negation of that is just P is not true, meaning P is false. So we should have a mathematical operator for this. So we are usually denoted like this. So it's like a sideways L of our statement P. What is this? Okay, so if we have the logical negation of a true statement, that's a false one, and the logical negation of a false statement is a true one, meaning that, okay, we want a function that takes in 1, spits out 0, and takes in 0, spits out 1. So we just have one, or a suitable function, or the most simple function there is that satisfies these conditions is just 1 minus p. So if we have a 0 here, we get a 1. If we have a 1, we get a 0. So it just flips back. And then for fun, we could just think about, okay, what happens if we take the negation of p? Well, you just plug in 1 minus p here, so you get 1 minus p, which is just p, which makes sense, because if you say not 2 times, it's the same thing. Okay, so okay, so that's the first one. And now, okay, let's think, okay, this is of course very related to like writing code, like programming. And what do you do there? Okay, if you have a Boolean, you have some kind of statement, what can you say? You can say that, okay, say if both are true, do this. If one of them or both are true, meaning or, if P or Q, say statement P and Q's are true, then execute this. And say, and yeah, and you can make them more, and we will create them all actually. Okay, so say you want a function and. So you want that, okay, so we have an and of P and Q. And we want this to be equal to 1 when both are true, meaning that both are equal to 1, and otherwise it should just be 0. So for this, we also just think for a bit, and then you would probably come up with this too. So the most simple function for this is just P times Q, because if one of them is 0, everything is 0, and for it to be 1, both have to be 1. So that's just P times Q. And now we can use this actually. So say that you want, and so first we just check that things are making sense at the moment. Okay, so I'll give you this statement. Okay, so we want P and the logical negation of P. Say we have this statement. This is of course never true, because both cannot be true at the same time. That's the definition of a logical negation. So, and now let's just use this math to prove that this can never be true. Okay, so we know that p, the and function says that we should multiply the two. So we just get p times 1 minus p. What is this? This is p minus p squared. And since p can only be 1 or 0, p squared is just p. So very suitable choice of numbers, yeah? So this just goes away, and then it's p minus p, which is 0, meaning it's false for all possible p's, which makes perfect sense. And this is why I love this branch of mathematics so much, just because you have these not really abstract, but in normal sense, like only verbal concepts, and then you can just turn them into pure mathematics. Yeah, I absolutely love this. Okay, so let's continue. Okay, so and then also you can add these up, like how much you want. So say you want an or. What is an or? Or is true. Okay, let's just make a quick little table here. Wait 5. So, okay, I don't know how well you see, but okay, what it says here is that basically P and Q is true, P is true, and Q is false. P is false and Q is true, and both are false here. So, okay, we have our AND function that we already know what the specific calculations are for that one, but we can just use this as a sketch. So what is it? This is true when both are true, and otherwise it's false. So, okay, let's think of this now. Okay, so we have an OR function. How do we want that to behave? Well, we want it to be true when one of them is true, and only false when both are false. So, how can we create an OR function now? Well, we could just put in all of these conditions. Okay, and for this OR function, we'll just, as with the same, the last ones, I'll just state the most simple function for this. So I have OR of P and Q. You could also write P or Q, that works just fine, like normal programming language. Then you would have a, if I don't remember incorrectly, I think it's PQ, sorry, it's P plus Q minus P times Q. Okay, so this is our OR function. Yeah, and just a quick side note. With this, we can actually, if you've studied some kind of like statement theory, or what the fuck you would call it, so you maybe recognize this. Okay, so the logical negation of P and Q is equal to the logical negation of P or the logical negation of Q. I can try to give you a good example here. So say that we have here, the car is blue, the car is round. I don't know what the fuck that would mean, but yeah. Okay, the car is blue and the car is sorry, and the car is blue, round. The car is blue and the car is round. So in here we have like all blue and round cars. And the logical negation of this would be everything that is not blue and round. So here, this is exactly equivalent to saying all cars which are not blue or all cars which are not round, which makes perfect sense. So yeah, I'll wait. So now we'll go back to this thing and expand on this a bit more. So yeah, be right back. So, okay, I'm back. So now say that we would like to create another function. Well, there is actually, you could call it exclusive OR. I think you often write it XOR. Now we would want this to be false when both are true and only true when one of them is true, but not both. And how do we figure out the function for this? Well, let's recall what we had before. We had for and, we just had p times q. But for or, it was a bit more complicated. It was p plus q minus p times q. So let's think about it this way. Okay, so especially with the or function, we had some constant, let's call it a, times our pq plus some constant b. In this case, in the or case, a was minus 1, b, which is just multiplied by p, was 1, and c was also 1. And then we just add a constant because we might need it for some specific functions. So we want this. We have this function, and we know what we should get when we plug in p is 1 and q is 1, and what we should get when we plug in p is 1 and q is 0, and so forth. So what we get is that we get a matrix, or we get a system of equations which we can change for a matrix. So we know that for the first equation, for this one, we know that both p and q are 1, meaning that we have 1a, 1b, 1c, and 1d. So yeah, here we should have the coefficient matrix, and here we multiply by all the constants. So we have a, b, c, d. We want this to be equal to our answers, essentially what we get here. I'll just I'll create we'll call this yeah, we can just call this x1, x2, x3, x4. I know boring names, but yeah, it works. Okay. And for the second one, when p is 1 and q is 0, then we don't get any a's. Actually, we don't get any a's for any later cases. So, okay, so we know p is true and q is false, meaning that p is 1 and q is 0. So we get a 1 here, and then a 0 here, and then a 1 here, and I can just fill in the rest of the cases. So we want to find our a, b, c, and d for any given one of these. What does that mean? Well, that means we need to find the inverse of this matrix, and this matrix is actually invertible, meaning that for every possible combination here, we can create a function, a logical function, which satisfies whichever needs we want. We can make a function that is false when both are true, true when only one is true, true when p is true, false when only q is true, and true when both are false. And you can calculate this using just the inverse of this matrix times well, this, which then would be 0, 1, 0, 1. So yeah, that's basically the point I wanted to get to. But what I really like about this field is just the fact that you can combine things in any way you want, basically. So actually, we could, if we had this, instead of doing with the inverse matrix, we could just use a bunch of ors to create this instead. So we could see this as, well, we have the condition p is true and q is false, or p is false and q is true, and then we would get exactly this. So I can just try to input that. So we know that or was minus pq plus p plus q, and in this case our p is p and not q, and our q is not p and q. So what we would get here is that our p is p times 1 minus q, and our q is q times 1 minus p. So we have this plus p times 1 minus q plus, and continue over here, q times 1 minus p. And if we expand these parentheses, we should get, okay, so in here we have p minus pq, and here we have q minus pq. Okay, so we should get a pq minus p squared q minus pq squared plus, sorry, I'm getting a bit messy here, but I think you'll manage, q squared, p squared plus q squared plus p minus pq plus q minus pq. And as we know from before, we can just erase all the exponents. They don't make any difference. So what we get, okay, we get that cancel out, so that thing, these two cancel out, and so here's the answer. We get a minus 2 pq plus p plus q. So that is the function we would get for our exclusive OR. This is our exclusive OR, actually, because if we look at this, okay, let's input both are 1, then we get minus 2 plus 1 plus 1. Okay, that's 0. That one works. If we plug in 1 and 0, since, okay, this function is very symmetric with p and q, so both of these cases are the same. If one is 0 and one is 1, then okay, this is 0, one of them, then we just get a 1, which we want for both of them. And if both are 0, then everything is just 0. So we get, so it works. And well, yeah, this was basically all I had. I'm sorry if the video got way too long, but I just really like this. And please comment if I should add something. I probably forgot like 5 things I wanted to say about this. So yeah, I just think it's really cool that you can do all these things. So yeah, that was basically all for me. So well, yeah, have a good one. Bye bye.